Okay, this fourth calorimetry problem is more like one of the ones that is expected on the exam in terms of it's just two Q values. So you're going to have a lead weight and you're going to submerge it in water. Okay, so again, we're back to a Q problem, which is mass times specific heat times delta T. Now, in this case, we're going to have the Q of lead equals the Q of water. One of them has to get a negative. Doesn't matter which one. So the easiest way to do this is I'm going to come to kind of the center of the page and set up my Q of lead is equal to my minus Q of water. So I'm going to go over here and I'm going to try to keep my equal signs in the middle. So I've got 2.85 grams of lead times, there's my specific heat capacity, 0.128 joules per gram per degree C. And we're looking for T final. So delta T, remember, is equal to T final minus T initial. And when we're done at equilibrium, the T final is the same for both because they're in contact. So that means that I don't know what T final is, but I know what T initial is, and it was 10.3 degrees C. Alright, so I got my equal sign, so now let's do our water. There's our negative. Don't forget your negative. I only have 7.55 grams of water. I have my specific heated water, which is 4.18 joules per gram per degree C. And my T final, again, I don't know what my final temperature is, but my initial temperature is 52.3 degrees C. Okay? Now, here's where we enter the ugly world of mathematics. Okay? So if we look at it and we do the math, we're going to get 0.3648 joules per degree C times TF minus 10.3 degrees C is equal to negative 31.559 joules per degree C times TF minus 52.3 degrees C. I'm going to try to isolate one of them. So the easiest thing is I'm going to divide both sides by 0.3648. So I end up with T sub F minus 10.